Okay, this shouldn't be difficult, so I'm going to try to keep it short and sweet. Absolute value inequalities. And you're saying to yourself, Mrs. Irwin, this is not an inequality. I want to look at an example that will end up with a solution that does not work, I hope. So remember, when we solve absolute values, we do a normal, or the original, and we do the opposite of the original. So I'm going to subtract the 2x and divide by 2. And I'm going to distribute add the 2x Now, I'm going to take each of these answers and I'm going to plug them in. And if I plug in 6 here and here, I get 12 plus 12. Absolute value of 24 is 24 equals 24. Yay. Take negative 2 and plug in here and here. And I get negative 4 plus 12. So this is 8. The absolute value of 8 is 8. And I plug in negative 2 here, I get negative 8. 8 does not equal negative 8. So this would not be a solution. It's called an extraneous solution. You're going to be seeing that a lot this year. So learn that vocabulary term. An extraneous solution is something that actually works when you do the math. You get it as a solution, but plugging it back in does not work in the original equation. So here's an actual absolute value inequality, and this is why I tell you not to just simply do this equation and then this equation less than negative 13, because you actually have to memorize, okay, on a less than, I have to make it an or an and I have to flip the sign, and I have to, just doing it like we were doing before, everything will work out on its own. So again, I'm going to write down the original, and I'm going to write down the opposite. Okay, so I'm going to subtract 5. Whoops, this should be, and divide by 4. Here, I can distribute the negative, but remember I can also divide by a negative 1 right up front, and I get 4x plus 5, but dividing by the negative switches this and changes the sign of that side. I'm going to subtract 5, and I'm going to divide by 4. So that's going to give me a negative 9 over 2, which is negative 4.5. Okay, now inequalities I put on a number line. So I always put a 0. I'm going to put the 2, and I'm going to put the 4.5. And I want x to be less than 2, and I want it to be greater than negative 4.5. So I'm going to be less than 2 and greater than negative 4.5, and that should be negative. Okay? So here, the first thing we have to do is isolate our absolute values. So we're going to subtract 4 from both sides. We get the absolute value of 2/5 n minus 8 is greater than or equal to 8. I'm now going to 2/5 n minus 8 is greater than or equal to 8, and the opposite of 2/5 n minus 8 is greater than or equal to 8. Over here I'm going to add 8, and I'm going to multiply by the reciprocal, and I'm going to get n is greater than or equal to 8 times 5, which is 40. Over here I'm going to divide by negative 1 both sides. When I divide by the negative 1, I'm going to flip my inequality. I'm going to add 8, multiply by the reciprocal, although it doesn't really matter because multiplying 0 by anything gives me 0. and I get n is less than or equal to 0. On the number line, I have 40 over here, I have 0 here, and this one on the right says n is greater than or equal to 40, so greater than or equal to 40. And this one on the right says n is less than or equal to 0, so less than or equal to 0. If you remember from inequalities, for an inequality that goes left and right, this is saying n must be any number that is 0 or less or 40 or greater. So any number over here or any number over here will satisfy this inequality. This is an or versus the and on the previous screen. So one more example, and the opposite of 19 minus 5t greater than 7. I'm going to subtract 19, divide by negative 5, which would switch my inequality, which leaves me at positive 12 over 5. Yuck. I'm going to divide both sides by the negative 1. I'm going to subtract 19, divide by negative 5, which is going to flip my inequality again. Oops, 28 over 5. This is 2.4, and this is 5.6. Let's graph that. So here's 0. Here's 5.6. Here's 2. Nope. .4 right there. And I want to be less than 2.4 and greater than 5.6. And there's your absolute inequalities.